These are homework problems for exercise 11.4. Question 4A is the first problem. We've got two similar triangles. The area of the large one is 175 centimetres squared. The area of the smaller one is 112 centimetres squared. So we can look at the ratio of the areas. Girls, because you have a calculator for this, I think you should just put in 175 ABC 112 on your calculator. So go 175 ABC 112. You will get a mixed numeral. I then want you to go shift fraction button. I'll just show you here on the calculator. You can go so we can go on this one, it would be 175 over 112. I didn't do it wrong. All right, yeah, you can't see it. All right, there you go. 175 over 112. Whoops, didn't mean to press that. Equals, and we get 25 to 16. Can you see that? So, but on the blue calculators or the school calculators, you get 1 and 9/16, which you then press the second function fraction button. So that's the easiest way. I would say, right, that's 25 to 16. The reason we stop there is we recognize that 25 is 5 squared and that 16 is 4 squared. So you need to simplify the areas until you recognize them as both square numbers. We're still not finished. That's the ratio of the areas. So now, therefore, the ratio of the side lengths is what? Is 5 to 4. Because if the ratio of the side lengths is 5 to 4, the ratio of the areas is 5 squared is to 4 squared. So we're working in reverse. Do you get it? So do you see why I simplified? Sorry, girls. Why I simplified the first ratio to 25 to 16 in the first place? Because 175 and 112 are not square numbers. You won't recognize them as square numbers. So you simplify the 175 to 112 on your calculator. You get 25 to 16. You then recognize those as square numbers, which are 5 squared is to 4 squared. So that's the ratio of the areas. Therefore, the ratio of the side lengths is 5 is to 4. Now, what's 11? Oh, the answer? Okay. Oh, sorry, it's exercise 11.5. Sorry about that. So now, girls, the 5 is for the bigger triangle. Girls, the bigger triangle will have the bigger area and the smaller triangle has the smaller area. So therefore, P over 20, now P is the smaller one and we're going to the bigger one, equals, no, 4, because they're side lengths now. Yeah, equals 4 over 5, yes, so P is going to be 16. 4 over 5 times 20, which is 16. Now, okay, the other way you might want to set it out, girls, excuse me, girls, the other way you might want to set it out, ladies, is with a table if you're getting confused. So you might go like this. We've got the ratio of the areas we know is 5 squared to 4 squared. The ratio of the side lengths, ratio, so this is the ratio, is 5 to 4. And you know that the longer one is 20. Do you know what I mean? You can see, so these are the actual lengths. Do you know what I mean? Some people might like to see ratio of areas 5 to 4, ratio of areas is 5 squared to 4 squared, ratio of the sides is 5 to 4, and then match up, you know, it's the bigger one that's got the 20 centimetre side. Can you see 5 times 4 is 20, 4 times 4 is 16? Or you set it up like that. You okay with setting it up like this? P over 20 equals 4 on 5. That over that equals the ratio of the side lengths, 4 to 5.
So you always use the side length for underneath?
The side length, ratio of the side lengths will go with the sides.
So you don't use the area?
No, because 20 and P are side lengths, they're not areas. No. All right, first I worked out the ratio of the areas. From that, I work out the ratio of the side lengths because you're trying to work out a side length. So you would never use ratio of areas with the P and the 20.
Do you use the ratio of area
if the question gives you something about an area? That's right. Okay. You use side lengths with side lengths and you use areas with areas. Okay, girls, next question in homework. Any problems? All right, I'm going to look at question 6 now. Well, I'm going to do 6 now as an example. Girls, this is exercise 11.5, question 6. It says a framed print has a length of 24 centimetres and a perimeter of 80 centimetres. A similar print has a length of 42 centimetres. So I've just drawn those out, that the length of this is 24 centimetres, the length of this one's 42 centimetres. We know that the perimeter of this is 80 centimetres. One sec. Okay, so we obviously don't know the area of this one yet, but we can work it out. If those are 24, what's 80 minus 20? So these two side lengths add up to 48. So 80 minus 48 is? And so there, 32 divided by 2 is 16. So these side lengths are 16. So now you can work out the area of the smaller shape. This one will be the smaller one. Area is 24 centimetres times 16 centimetres, which is 384 centimetres squared. Now, before we can work out the area of this one, we do have some corresponding side lengths, and we can work out the ratio of lengths. Are we okay with that? So, ratio of side lengths is what is to what? Give me two side lengths that are corresponding. 24 is to 42. You need to simplify that fraction by doing 24 ABC 42 on your calculator. And what do you get? 24 ABC 42 equals, anyone? I think you can divide them both by 3. Is it? So, we divided them both by 6, sorry. 4 to 7. So that's the ratio of the side lengths. So therefore, what's the ratio of the areas? 4 squared is to 7 squared, which is 16 is to 49. So, do you know which one matches? The 16 goes with the small one, the 49 goes with the large one. So let's work out our area. So the area, so this is what we're trying to work out. Area over what? The area of the big one we don't know. What's the area of the small one? So A over 384. Be careful. This is the big rectangle over the small rectangle. So I need the big ratio over the small. 49 over 16. Because the rate, so A over 384, you can tell by the side lengths which one's the bigger. The bigger rectangle will have the bigger area, won't it? So A over 384, so we're going from bigger to smaller, equals 49 over 16. So therefore A is 49 over 16 times 384. And what do we get?
1,100. Is the 49 the other side length?
No, the 49 is the ratio of the areas. The 16 to 49 is the ratio of the areas. So then we set up an equation. So that area over this area will equal that area over that area. So, for example, if the big one, you could double these numbers, times them by 10, times them both by 5. Like, that's just the ratio of the areas. So you do the ratio of these areas equals that ratio. Do you understand why we're doing areas with areas? That over that will equal that over that. You don't understand why. We're trying to work out the area of the big one. Do you?
You guys get confused because it's 49. So just which one's which? Is the A the big rectangle?
Yes, A is the area of the, look, I've drawn diagrams here. How can you tell it's the big one? Because this is a side length of 24 and this is a side length of 42. So which one do you think is the big rectangle?
What do we need the ratio?
So it's 49. One area.
You're trying to work out the area of the large one. You know the area of the small one. That's why. So if you know the area of the small one and the ratio of the areas, you can work out the ratio of the large one. If that ratio was 1:2, for example, means the big one would be twice as big.
Yeah, Miss is looking at the ratio, not the side length.
Yeah.
Looking at the ratio of the area.
Oh, okay.
All right. What have we got, girls?
1176.
1176. Okay. There is another way without using, you still don't get it, do you, Michaela?
No, I get it. No, it's just that I was about to say you can just times it by 24. 49 times 24. I was just going to say that.
Let's see. Just the same as ratio of areas. Now, sphere A is similar to sphere B. The radius of sphere A is 2 centimeters, and the radius of sphere B is 5 centimeters. You may not be able to read it properly. These spheres are the same shape, they're just balls, but they're different sizes. So how many times bigger is sphere A than, sphere B? It's 2.5 times bigger. Now, surface area formula, anyone remember it? 4 pi r squared. So it's 4 pi r squared. So it's 4 times pi times, what's the radius of this one? 2 squared. 2 squared is 4, so what's this going to be? 16 pi. This one is 4 pi times 5 squared. So that's 25 times 4, which is 100 pi. So the ratio of the lengths we can see, this is lengths, is what? 2 to 5. So therefore, all right, let's see what we get for our ratio of surface areas. We've got 16 pi is to 100 pi. What can I drop? So it's 16 is to 100. Write those as square numbers. Isn't it just 4 squared is 2? All right, let's simplify that actually. That can be simplified, so get rid of that. They're both even. What can you divide them both by? 4 to 20. You can divide them both by 4, so it's 4 to 25 goes there. Now write them as square numbers. Girls? 2 squared, but we knew that anyway. We knew we were going to get 2 squared and 5 squared because the ratio of the lengths is 2 to 5. So the ratio of the surface areas, which is just area of all the faces, should be 2 squared to 5 squared, and we got that anyway. So therefore, in conclusion, for two similar solids, if the ratio of the side lengths is A to B, then the ratio of the surface areas will be A squared to B squared. Okay with that? Right, we'll keep going. Got that, girls? Girls, come on. All right, next page. Volume. We've got the same similar shapes again. We're just going to look at the volumes of the 3 shapes. So, similar solids have the same shape but different sizes. One solid can be thought of as an enlargement of the other. Cube A is similar to cube B, but the side lengths of cube B are how many times the side lengths? Yep, they're 2 times the side length. It's double the size. So, volume of cube A. Remember, all the side lengths are 2. How do you do the 2 times 2 times 2, which is 8 centimeters cubed. Volume of cube B. 4 times 4 times 4, which is 64 centimeters cubed. So therefore, the ratio of the side lengths is 2 to 4, and simplify that, 1 to 2. We okay, girls? The ratio of the volumes, let's write in our volumes, we've got 8 is to 64. What can you divide those numbers by? 8. You can divide them both by 8, which is 1 is to 8. Now, writing them both as cubed numbers, 1 cubed is 1, isn't it? And 2 cubed is 8. Can you see the pattern now, girls? So, if you've got your ratio of side lengths, if you're looking at the area, it'll be side length squared. And if you're looking at the volume, it's side lengths cubed. It makes sense. You know that volume is cubic units, and that area, whether it be normal area or surface area, is always squared units. So that tells you what to do with the side lengths. Does it make sense? All right, let's do the next one. Cylinder. Do you remember how to work out? Volume of a cylinder is not as tricky as surface area of a cylinder. Volume will be the area of the cross-section times the height. So what would be the area of the cross-section? How do you find the area of that cross-section? No, it's pi r squared is the area of the top times height. So the volume of a cylinder is volume equals pi r squared times h. Now, cylinder A is similar to cylinder B. Cylinder B has dimensions that are how many times bigger? Well, look, yeah, 3. The radius has been multiplied by 3, and so has the height. So it's 3 times larger. The volume of cylinder A, volume of cylinder A is pi times, radius is 1 times 2. What have we got? 2 pi centimeters cubed. Just put the units in. Volume of cylinder B, pi times radius squared times 6. Now 3 squared is 9. 9 sixes are 54 pi centimeters cubed. So let's look at the ratio of the side lengths. I don't mind if you choose the one with the 3 or the 2 to 6. I'll choose the heights, 2 to 6, which simplifies to ratio of volumes. So let's just write down what our volumes are. 2 pi is to 54 pi. What can you divide? You can divide them both by pi and get 2 to 54. But what can you divide both those by again? So you can divide them both by 2, which is 1 is to 27. And now 1 is 1 cubed and 27 happens to be 3 cubed. Notice that if the ratio of the side lengths is 1 to 3, the ratio of the volumes is 1 cubed to 3 cubed. Is it making sense? All right, everyone good? Can I turn over the page? Right, last page, volume of spheres. So, sphere A is similar to sphere B, same shape, different sizes. All right, the radius of this, you can't see it, is 2 centimeters. The radius of the big one is 5 centimeters. So, how many times bigger is sphere B? 2.5 times bigger. Volume, formula for volume of a sphere, because volume's cubed, that's how you remember it's the one with all the 3's. You know how surface area was 4 pi r squared? Volume of a sphere is 4 on 3 pi r cubed. So you can just think volume's cubic units, it's the one with all the 3's in it. Surface area is squared units, it's the one with 4 pi r squared. So that's the formula, 4 on 3 pi r cubed. We did it last year. All right, volume of sphere A, 4 over 3 times pi times 2 cubed. Well, girls, that's 8. 8 times 4, 32 on 3. So you just got to keep it like 32 over 3 pi. The volume of sphere B, 4 over 3 times pi times 5 cubed. 5 cubed is 125. 125 times 4, 125 times 2 is 250. 500 over 3 pi. Because it's going to be easier to do simplifying the ratios later. Now, ratio of lengths. Now, ratio of volumes, we've got 32 pi over 3, 500 pi over 3. You can drop the pi's, right? So let's do that. 32 over 3, 500 over 3. You know how I've divided them both by pi? You can drop the 3's. You can times both sides by 3, and the 3's will go.
Is it 32 over 3 pi centimeters cubed?
Yep. Centimeters cubed, centimeters cubed. Okay, girls, so drop the pi's. When I say drop the pi's, you're really dividing both sides by pi. When I say get rid of the 3's, I'm really timesing both bits of the ratio by 3. Watching. No, because it's not going to help us. I need to get rid of those 3's. So if I times that by 3 and I times this by 3, watching. I've got 32 over 3 and 500 over 3. So if I times both the left-hand side of the ratio by 3 and the right-hand side of the ratio by 3, the 3 up there cancels with the 3 down there. The 3 down there cancels with the 3 up there. So it's 32 is to 500. Girls, they are not square numbers. Go 32 ABC 500 and you will get the simplest ratio. 32 ABC 500. 8 over 1 and 125. Now you can see cubic number. So that's 2 cubed is to 5 cubed. Girls, you really need to pull the calculator out and do that. Otherwise, you're going to be sitting there. Look, you could halve them both and get 16 is to 250 and halve again, and you'll get 8 is to 125. You will eventually get there, but it's much quicker. Ladies, it is a calculator section. You're allowed to use your calculator.
Is there going to be a calculator section?
No. I just said it was a length is A to B. Then the ratio of the volumes is A cubed is to B cubed. So girls, for areas, it's A squared to B squared. For volumes, it's A cubed to B cubed. Okay? All right. Girls, I need to do some examples on surface area and volume. Books, could you please write that following heading? Exercise 11.6, volume and surface area of similar solids. And I will put up some examples now. Do question 1E, part 1 and 2. Just looking at the problem, you can see that ratio of, look, I'll do a quick sketch, but then I'm going off this screen, okay? Girls, I'll show you how to draw it. So we've got 18 to 24. This is what, here, this is what you've got. Shh. Girls, so the way you draw it, I wouldn't draw the whole lot. Just draw your front-shaped trapezium. Girls, you watching? And then just go back, 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 and that'll do. So, 18 to 24. Girls, the first question's really easy. It was 18 to 24. So it's question 1E. We want the ratio of the surface area of A to B and volume. So, ratio of lengths. What's the ratio of the lengths? Girls, we're finding the ratio of the surface areas and the ratio of the volumes. Ratio of lengths is 18 to 24. The problem, girls, is that that's not a simplified ratio. Yeah, and that's not simplified either. Well, girls, just go 18. Girls, I'll tell you now, just go 18 ABC 24 equals. You can divide them both by 6. That's your other thing. But I don't want just 9 to 12 and you stop, because that can be simplified and you're making it harder for yourself. I want the simplest ratio. And it's 3 to 4. Therefore, ratio of surface areas is what? No, it's 3 squared to 4 squared, which is 9 to 12. And the ratio of the volumes is 3 cubed to 4 cubed, which is 27 is to 64. Okay, so girls, that's fairly straightforward. Surface area is just like area. So ratio, I'll write the full word there, surface areas is 9 to 16, ratio of volumes 27 to 64. Girls, I really want to move that. I need to get some more questions. I need to look up the next question and I can't. Oh no, I'll just look it up over here. All right, I'll just move this out of the way. All right, I'll do another question. All right, I'm just going to do it in summary form, the question. I'm now doing question 2A. I think they're all similar in 2. I will do a harder one. Yeah, well, if you're nice and quiet, I might get through it. Girls, when you write the question out, I don't want the whole thing written out. This is question 2. Shh. Yep, they're both square. They're just both prisms. Shh. And it says, shh, is it exercise 11.6, question 2A. It says, sorry girls, they're meant to be squarish, all right? It says the area of the top face of the larger prism, the area of the top face of the larger prism is 80 centimeters squared. Find the area of the top face of the smaller prism. So this is how I would write the question out if I were you. You can go, oh, I'll just show you the question down here. There's the question. The solids below are similar. The area of the top face, I've just done it by drawing. The area of the top face is 80 centimetres squared. We know that the side length there is 4. And the area of the top face here is question mark because it's saying find the area of the top face. We know ratio of side length. So how are you going to start this question off? So, okay, that's what I'd start with. You have to find the area of the top face. So you start with the ratio of side length. So girls, they want the area of the smaller one. Can we stop, girls? Just make sure your answer for the smaller one is smaller than 80. Does that make sense? All right, ratio of the side lengths is 4:3. Therefore, the ratio of surface areas or even just areas, it doesn't matter because they've just done the top face, which is just an area. So what would be the ratio of the areas? 4 what? 4 squared to 3 squared. 16 is to 9. So we want that one. Well, it doesn't matter. It's the same. They just want the area of the top face. So I'm calling it areas. It doesn't matter. So what goes with what? A over 80. So girls, A over 80 is what? I'm going from there to there. 9 over 16. So therefore A is 9 over 16 times 80, which is whatever. 16 into 80 is 5, isn't it? It's 45. 45 centimetres squared. Doing another one. Yeah. All right, let's try and get one more done. I might have to do a homework video. All right, girls. I'll be doing it. I'm free in period 2. I'll do it right now. I'll stop. Actually, I'll do a separate one. All right. Otherwise, it takes